Dang. Oh, I'm sorry. I didn't see you there. I was busy playing my Xbox. You know, I spend a reasonable amount of time playing video games each day, and I wanted to see just what factors go into determining how much time I actually spend playing. So in order to do that, I collected data on myself over the last 40 days, and I'm going to use a factorial ANOVA to determine the correlation between several independent variables and the amount of time that I spend on video games. So in this situation, my null hypothesis is going to be that having school and or work on a given day will not affect how much time I spend on video games. Therefore, my alternative hypothesis is that having school or work does have an effect on my time playing video games. So, with that said, let's take a look at the data and see just how much of an Xbox addict I am. So let's start with the data that I collected. I recorded my time playing video games over 40 days and categorized the data into 4 groups using 2 independent variables. These 2 variables are whether I work that day, factored into a yes or a no category, and whether I have school that day, also factored into a yes or no category. This results in our 4 groups, which are work and school, work and no school, no work, and I do have school, and finally, no work or school. Now, weirdly enough, when I took these samples, the math worked out so that I have 10 samples for each category. Luckily for me, this makes our next steps easy. So let's take a look at the results generated by JASP. To do this, I uploaded my Excel datasheet into JASP and put the minutes column into the dependent variable box and the work and school categories into the fixed factors box. This gives us the F and P values for each category, as you can see on the right-hand side of the chart. So let's start by looking at the work category. If we look into the marginal means box, we can see a difference of almost 40 minutes between the yes and the no marginal means, and a p-value of less than 0.001. With this, we can say that whether or not I work does indeed have a significant main effect on my time playing video games. Now, if we look at the school category, we'll see similar data. So with a difference of nearly 50 minutes in the marginal means and another p-value of less than 0.001, we can also say that school has a significant main effect on my time spent playing video games. Finally, if we look at the interaction between school and work, we'll see a p-value of 0.554, which we can say pretty safely means that there is not a significant interaction effect. So with all that said, let's look at a visual representation of this data. So the first thing to note here is that the lines do not cross, meaning that there is no interaction effect between the independent variables. We can see that work does have an effect, as both data points in the no work category have higher values than in the yes category. We can also see that school has an effect, as both data points on the no school line have higher values than the yes school line. So really, what we have here is a simple visual representation of the data that was shown in the ANOVA chart and the F and P values that we got from that. So, in conclusion, we can safely say that whether or not I have school or work does have a significant effect on how much time I spend playing Xbox. Although there is not an interaction effect between the two, both independent variables had p-values of less than 0.001, showing that they both definitely had statistically significant main effects. Using this data, I'll be able to predict just how much time I waste in a given day, just based on what else I have to do. So thank you for taking the time to listen to my presentation, and thank you for giving me the tools to figure these things out for myself.